Hello and welcome to National 5 Maths. This is some revision. Today's revision will cover multiplying out brackets, so expanding the brackets, and also factorising, and that covers difference of two squares, completing the square, and we will also do some simplifying algebraic fractions. So let's make a wee start. Right, okay, first of all, multiplying out brackets rather. The easiest type of question you can get is one like this. Now remember, if you were asked to do this in an exam, it would say multiply out or remove the brackets, or it might say expand the brackets. It means all get rid of the brackets, okay? So x times x squared, x times negative 7, negative 7x, and then the plus 3 gets multiplied by the second bracket. Positive 3 times x, and positive 3 times negative 7. 3 7's 21, negative 21, because it's a positive times a negative. Now remember, some terms can get collected together there. X squared, that first term, there's no more x squareds. These terms in the middle here, negative 7x, add 3x, negative 7 add 3, would be negative 4x. And that's that one done. Okay, I'm just going to work through a few different types of multiplying out brackets. So the next type of multiplying out bracket question you could get could be one like this. Now, the squared, remember, squared means multiply it by itself. So what we actually are doing here is multiplying the 2x minus 3 by another 2x minus 3. Okay? And just do the same as question 1. 2x times 2x, 4x squared. 2x times negative 3, negative 6x. And now we're going to multiply the negative 3 by both terms. Negative 3 times 2x. And negative 3 times negative 3. Two negatives give a plus 9. And again, collect any like terms together. 4x squared, negative 6, take away another 6 more, we're actually negative 12x altogether. There we go. Okay. Another type of multiplying out brackets question that you could be asked to do could be one like this. Okay. We'll multiply out the first terms. 4 times 2x and 4 times positive 3. 4 3s are 12, plus 12. The second bracket now, subtract. Think of it as, I would tend to think about this as a negative 2 multiplying by x. So negative 2 times x is negative 2x. Oops, that is an x. And negative 2 times the negative 3. Negative 2 times negative 3 is a plus 6. And again, collect any like terms together. 8x, take away 2x. 6x. A positive 12, add 6 more. Plus 18. Okay? And the final multiplying out bracket type question that you could be asked would be one of these type. And this should all look pretty familiar. Okay, so what happens here is the 2x gets multiplied by all the terms in the second bracket. 2x times x squared gives us 2x cubed. 2x times another 2x in the middle, 4x squared. 2x times negative 4, negative 8x. Now I multiply the negative 3 here by all the terms in the second bracket. So negative 3 times x squared. Negative 3 times a positive 2x, negative 6x. And negative 3 times negative 4, two negatives multiply to make the positive 12. And at the end, obviously, collect any like terms together. We've got a 2x cubed. 4x squared, there's more x squared, there's a take away 3. 4 take away 3, we've only got 1x squared left. We can write it just as a plus x squared rather than a plus 1. Negative 8x, take away 6 more. Negative 8, take away 6 more. Negative 14x. And don't forget there's a wee plus there at the end, a wee plus 12. Okay? So this is all on multiplying brackets out so far. I think that was number 4. There's one more multiplying out bracket type question that I'm going to show you. We'll say across the bottom is 2x plus 3, and we'll say up the side is x minus 2. And the question is, what is the area of the rectangle? Now the area of a rectangle is the length times the breadth. So we want to multiply the 2x plus 3 by the x minus 2. And that's how we write that out, that we're multiplying them by each other. And correct, we're going to just multiply this out exactly the same as before. 2x squared minus 4x plus the 3 times each of the numbers in the second bracket, plus 3 times negative 2, negative 6. Collect any like terms together. 2x squared, all them together, take away 1x minus 6. So that question there, you'd be asked, give an expression for the area of the rectangle. And the area, obviously, we've multiplied out the brackets, the length times the breadth. Right, we're going to move on to a bit on factorising now. Generally, we think of factorising as the reverse or the opposite of what we have just done, okay? So this is a wee bit on factorising. So when it comes to the exam, remember you'll get 1 or 2 questions on multiplying out brackets and potentially a couple of questions on factorising as well. The easiest type of factorising question is a question like this. The easy type of factorising is take out a common factor. Is there a letter or a number, or perhaps a letter and a number that's common to them? Yes, there's not a letter, but there's a number. 7 is the highest number that goes into both of those terms. So we take out the 7. If we take out the 7, what do we put in the bracket so that we multiply it out? We get 21a. 7 times 3a. Take away. 7 times what do we need to put in the second part of the bracket so that we multiply it, we get 28b. 7 times 4b. And that's how we factorise along the lines of the common factor method. Okay? I'm going to go through an example or two on each of the different types of factorising methods. So, next type of factorising method that you should know how to do is one like this. So you'd be asked in each of these questions to factorise. That's a 24 there at the end, okay? Right, so in this question, there is not a common letter or number in each of those terms. You cannot take out a common factor. You should be able to see that this is one of these ones. You should know what it looks like for the answer. It's a quadratic or a trinomial type question. We are looking for 2 numbers that multiply to negative 24, and the same 2 numbers need to add up to 2, positive 2. So let's think, 2 numbers that multiply to negative 24. 3 8s, think of the signs, okay, I'm going to note them down here. Negative 3 times positive 8, or remember, positive 3 times negative 8. Do any of those combinations add up to positive 2? No, none of them. 6 4s are 24. Negative 6 times positive 4. Remember, one of them will have to be negative and one of them will have to be positive to result in a negative 24 when we multiply. Right, any of those ones, are they going to add up to a positive 2? Well, the top one, negative 6 plus 4, is a negative 2, so it's got the 2, but it's a negative, so it's not that. Positive 6 add negative 4 is positive 2. That's the one that we need. So in the bracket, we write an x plus a 6 and an x take away 4. You could have in the first bracket the x take away 4 if you wanted, and the x plus 6 in the second bracket, but it must be a plus 6 and a negative 4. Right, another type of factorising question is one like this. And again, you would be asked to factorise. How do you factorise this? Well, it certainly hasn't got three terms. It's not the trinomial like the last one with the double bracket type question. There's no common factor. You can't take out x as a factor of, there's no number that in front of the x squared apart from 1. There's no common factor in terms of like the first example. This here, give you a wee hint. It does look like this. I'm hoping it's coming back to you if you're still not sure. And the number that goes in each bracket, one's a plus, one's a minus, is 4. This is what we called the difference of two squares. And it's when we have one term squared, take away another term squared. That 16 is also 4 squared. Right? Hopefully that looks familiar there. I'm going to do another type of factorising. Next type of factorising is an example. Here's a wee example here, right? This one sometimes catches people out a wee bit. 3x squared minus 27. Right, first of all, always check for a common factor. Like we did the last time, there was no common factor. There is a common factor here. 3 goes into the 3x squared and 3 goes into 27. All I'm doing is I'm taking out the number 3 as a common factor, just like I did in example number 1, common factor method. If we take out the 3, it's an x squared, and obviously we've taken out the 3, 3 9s are 27. However, this is not finished now, because the bit inside the bracket is exactly this bit here, is exactly one of them. A difference of two squares. So I can factorise the x squared minus 9 by doing two brackets side by side. X times x for the x squared. 3 times 3 gives me 9. One's a plus and one's a minus. Okay, the 3 at the front must be in the answer. Don't let that number 3 at the front, the common factor, don't let that disappear. And that's us. Okay, quick wee bit on completing the square now. Completing the square is a type of, I suppose it comes under a type of factorising. It's when, let me just get an example for you. The type of question we are looking at here is you'll be asked, tricky questions, right, you'll be asked to write in the form, and we had one of these recently to be honest, x plus a squared plus b. So we need to write the answer looking like that. So the question is x squared plus 4x minus 7. Okay, so we need to write it looking like this. I'm hoping it sounds familiar. It needs to look like that. It tells you that in the question there. So the method is to half it, square it and subtract it. Half this, half the plus 4, we put in a plus 2, not a plus 2x, an x plus 2. So that's the half it. Now we square the 2. 2 squared is 4. What do we do with the 4? We subtract it. Now it's not finished because we've still got the negative 7 to deal with. The actual answer, I know some people do this slightly different, as long as you get the final answer correct, that is all that matters. That line that I've just put there, the second line, is not actually needed. You can go from the beginning straight to the end, which is this. Okay? Half it is a 2. Square it is 4, take away the 4, don't forget take away 7. So altogether, when you take away 4 and take away 7, you've actually taken away 11, which is why we've got the take away 11 at the end. Okay, next quick wee bit on some simplifying, and we are going to simplify some algebraic fractions. Okay, you will always get a couple of questions like this in the exam. So these are on simplifying algebraic fractions. You'll be asked to simplify. So, first one, the easiest type of simplifying, something like this. Okay. Right, look at your numbers. 12 over 20. we can do a wee bit of simplifying with the numbers. Divide the top and bottom by, what's the highest number that goes into them both? Divide them both by 4. So that's going to be a 3 and that's going to be a 5. Right, so what about the A's? I'll do it in different colours. I don't know if it makes any difference. We can simplify the A's. We've got 1 at the bottom and we've got an A squared at the top. Simplify them. We're going to be finishing with just 1 A on the top because you've got 2 A's at the top, 1 at the bottom. Take 1 off the top and bottom. You've got just 1 A at the top. B's don't simplify. The final answer here is actually 3A B cubed, they're still at the top, and on the bottom the A's gone, the 20 has been reduced to the number 5. That is it. Okay? Right, that's a pretty straightforward simplifying algebraic fraction. The next one is a bit more difficult. Okay, we're going to run through a couple of examples and it'll be a very short video this time compared to normal, I think. Right, okay, simplify. This is all based on simplifying, okay? Right, simplify this. How do you simplify? To simplify, you'll notice at the top here is an expression. In question 1, they were all multiplied with each other in the top line, and in the bottom line they were all multiplying with each other, so that's why we just did a wee cancelling out. You can't do that here. The top there is an expression, so to factorise, to simplify, we factorise. Factorise the top. We can take a common factor out. If you take a 2 out, you've got p plus 4. So we've factorised. And now you can do along the lines of what we've done in the first example. We can do a wee bit of division. Divide through by 2. Divide 2 at the top, 2 at the bottom. Gives us an answer of p plus 4 at the top. Divide the bottom by 2, we're dividing top and bottom by 2, makes it a 5. Okay? Right, number 3. Next type is, let's see, and again, remember the question would say simplify. That's what the question would say. Simplify this algebraic fraction. Right, so, like number 2. At the top we have an expression here, so we're not going to simply cancel out, oh here's take an A off the top and take an A off the bottom. No, we need to factorise. Factorise the top. Look at the top, that's an A squared. I know it might not look it, yeah it's not bad. That's an A squared. Is there a common factor at the top? We're doing each part, top and bottom, separately by factorising both terms, okay? At the top, A is a common factor. Now, if you take A as a common factor we only need the one bracket, remember. We need A, take away, we've taken out A as a common factor, we just have a B. Right, look at the bottom, 3A minus 3B. It's not difference of 2 squares, not trinomial, it's just a common factor. What's the common factor here? 3. If you take out the 3, we need an A minus a B. And there we go. What do you see that's common to the top, that's identical at the bottom? The whole bracket can cancel out, resulting in just an A at the top and just a 3 at the bottom. That there, what we've just done, which we have resulted in cancelling out a full bracket, that is a common type of thing that happens when we do the simplifying with the algebraic fractions. Okay, that's what you're looking for. Right, this will be the last one. And again, remember what we're doing here is we are simplifying. You'll be asked to simplify. Right, factorise the top, factorise the bottom. Don't start scoring out x's top and bottom. That is not what you do. You factorise. Right, this is the 2 brackets at the top. We'll do that one first, then we'll sort the bottom. X times x. So we're looking for 2 numbers that multiply to the positive 5. The same 2 numbers need to add up to negative 6. Right, 2 numbers that multiply to positive 5. A positive 5 times a positive 1. They multiply to 5. Do they add up to negative 6? No, they don't. Remember, negative 5 times negative 1 also multiply to positive 5. 2 negatives make a positive. And they also add up to negative 6. So, that's us. X minus 5 and an x minus 1. On the bottom, is there a common factor? No, there's not a common factor, but we can still factorise. I'm hoping you're working a wee step ahead. It's a difference of two squares. X times x gives us x squared. What number do we square to get 1? 1 times 1 is 1. Wonder if I caught some of you out there. And now that we've factorised top and bottom, just like the last time, there is a part, an expression on the top and the bottom, a whole bracket that can cancel out top and bottom. There we are. Now that is what you're looking for when you're factorising. Oops, it's x minus 5 at the top. X minus 5 and an x plus 1. That is what you're looking for. When you're factorising or simplifying an algebraic fraction, you're looking for a whole bracket to cancel out at the top with an identical bracket at the bottom. And if when you factorise you do not see an identical bracket top and bottom, you've probably done something wrong. Okay? Right. We went over quite a bit there. I want you to go and have a wee go at my quiz now. Okay? Right, good luck. Bye-bye.